Math 3, Unit 4, Section C, or 4.3. So we're talking about adding and subtracting rational exponents. The first thing that we need to pay attention to is, see how this has root n and root n? That means that we can add the parts in front together. Okay, so that's why they have a plus b like this, because we don't really know what a and b are. And then you would have the root at the end. Same thing, you can subtract them. The thing to pay attention to is that they have to have the same index number. If they don't have the same index number, you can't add or subtract them together. Okay, so on A, can I simplify that? No. No, why not? Very good. So we're just going to put cannot be simplified. And I'm just going to put indexes are not the same. And again, in your notes, you don't, or not in your homework, you don't have to write all that. I just like you to put it in your notes so that when you look back, you understand why you couldn't add them together. Okay. Now, also when you're adding roots, the insides needs to be the same as well in order to add them. And so in this case, see how they're both the square root of xy? So we can add the outsides. Can you add 3x plus 4x together? Yeah. So it's just 7x, and then you keep the same root. So that's it. So it's just like, it's almost like if you were adding like 3y plus 5y. You can only add them if they're both y's, right? And then you add them together, and that becomes 8y. It's the same idea here. In order to add them, the roots have to be exactly the same, and then you just keep that same root, and you just add the numbers that are in front. Okay? All right, so then C. If you look here, they all have the same indexes, but the roots themselves are not the same. So right now, I can't add these together because the inside needs to be the same. But if we go through and break them down, they could end up being like. And so can I break down 250? To what?
2 and something like that. 125.
You could do 2 and 125. I'm going to do 25 and 10 because I noticed like whenever anything ends with a 0, it's a 10. And so I decided to do 25 and 10, but you could do it the other way. And then 25 is 5 and 5, and 10 is 5 and 2. And how many do I need to make a group on this one? 3. And so what will this answer for this first part end up being?
5 and 2.
Very good. And we'd write that, though, as the 5 cubed root of 2, right? So make sure you keep that index. Okay, so then 54. What numbers multiplied to be 54?
6 and 9.
6 and 9, good. And then 6 is 2 and 3. 9 is 3 and 3. So we have a group of 3s and a 2 left over. And so I end up writing that as, perfect, 3 cubed root 2. And then the last one, 16, breaks down to 4 and 4. And then we know that each 4 is 2 and 2. And so I end up with a group of 2s and a 2 left over. And so we end up writing that as minus 2 cubed root 2. Very good. And now you can see that each of these has the cubed root of 2. So can I combine them all together? Yes. So all we're doing is taking that front part, and so we have 5 plus 3, which is 8, and then 8 minus 2 is 6. So my answer is 6 cubed root of 2. Okay, so I'm going to give you about a minute. I'd like you to try D on your own. Yes. Sorry, it was 6 cubed root of 2. I'll put that back there for you for a minute. Mm-hmm. Okay, so the answer is 5 cubed root of 2, and as I look around, a lot of you have it. Okay, so 54 breaks down to 9 times 6, and then, and then we get 3 and 3, and 3 and 2. So we have the 3 cubed root of 2, and then 16 we know breaks down to, I'm just going to write the 4 2's. We have 3 2's with a 2 left over, and so we get plus 2 cubed root of 2. And we add those together, which makes 5 cubed root of 2. Any questions? Okay, so 81, same thing. We're just going to break we're going to break 81 down. So 81 is going to break down to what? 9 and 9, and then each 9 is 3 and 3. And so we need 3 for a group here. So we have 3 with a 3 left over. And what happens when I bring that group out? Multiplies. So we get 9 cubed root of 3 minus, and then 54, 9 and 6. We've kind of done this one a few times already now. So we have a group of 3's, 2 left over. When I bring that out, it becomes, good, 6 cubed root of 2. And then 9 minus 6 is 3.
That doesn't have the same inside.
Good. We can't do that, can we? So that's it. That's your answer. Good job. And in fact, we're going to make a note here that we cannot simplify since the, and do you guys remember the name for the number inside? Radicand, I think. How is that we say it? Radicand is different.
Is it that figure?
Oops, and you can't see what I was writing, but that's what I wrote.
So you just leave it as trash?
Yep. So you simplify it. You simplify as much as you can, but if they don't have the same index and the same radicand, then you would not be able to simplify any further.
I'm really confused. What do you mean?
Do you see right here how this is a 3 and this is a 2? We can't combine them
So
since
those
they're
have to be the same.
as well as the index.
Oh, so both of them.
Yes.
How come you put the 9 in front and like on the other ones you just did the 3? Like on D, how do you just move 3 down and 2? How can you like multiply?
Okay, do you see on this one how there already is a number in front? And so when I brought the group out, I multiplied it to there. So the group that I brought out was a 3, and there was already a 3 there, which made a 9. On this one, the group was 3, and there was already a 2 outside, so you multiplied the group times the 2, which made it a 6. This one didn't have a number in front to start with.
Okay.
Is that better?
Yeah.
Okay. All right, any other questions? We're good? Okay, so the next ones we're multiplying, and this is where you have to be a little bit careful. How many of you use the FOIL method or like the distributed property method? How many of you use the box method? Okay, so I recommend using the box method, and what I mean by that is there's 2 terms here, so I'm going to use a box that's 2 and then by 2 because there's 2 terms there. If we had 2 by 3, then I'd use 2 terms, 2 by 3 box. Okay, so I'm going to make a 2 by 2 box. If you want to use the FOIL method, you can. I just like the box because it you know that you're going to multiply something for every single one of those spots, and it organizes it so it's easy to add. And then it doesn't matter where you write things. So you have 3 and a 2 root 5 on one side and 2 and 4 root 5 on the other side. And if you have negative signs, you want to make sure that you keep the negatives with those numbers, but in this case, everything's positive. And then for each box, we're just multiplying. So this box is 2 times 3, which is 6. And then this box, because the 2 is not in a root, it multiplies with the number not in the root. So 2 times 2 is 4, so that's going to be 4 root 5. The box down here, we're going to multiply 3 times 4, which is 12, and that's 12 root 5. And now this box, We have 4 times 2, which is 8. And then we have a root 5 and a root 5, which is going to become what? So I'm just going to write it as root 5 and root 5, or like 5 times 5 under the root, which makes a pair, right? And so that ends up becoming what? 5, right? This would just become 5 because we have a group, and then you multiply times 8, which would make 40. So I'm going to end up just crossing this out and putting a 40 here. Okay.
Just a reminder to all staff who would like to participate in the No Shave November fundraiser, please come to the front steps of the front office.
I'm not
No
participating.
Shave
Sorry.
November. Those of you that want to participate, staff members, please report to the front steps of the front office.
vote for no shave November.
Okay. So back to this. When you were writing your answers, you need your real part first and then your root part second. So if you notice, there are 2 numbers that can be added together that are real. And so 6 plus 40 are when I should, yes.
I don't understand why it's 40 though.
Okay, so here to the side. 4 root 5 times 2 root 5. And so both of the outside numbers multiply together. 4 times 2 makes, so we're multiplying 4 and 2, right? 8. And then with the roots, you get to multiply those together. So you have 5 times 5. So remember how when we were multiplying, we could just put them all under the same root? And then this is a square root, so you need 2 of the same thing. And so we have 2 of the same thing, and so that's a group of 5s. And when you bring it out, you multiply the 8 times 5 together, which equals 40. And so we write our number without a root first. Okay? Both of these numbers are real. It's just we're doing that number in front first. So we have 46 plus, and then since these are the same roots and the same radicand, we can add them together. 12 plus 4 is 16 root 5. And so that's my answer.
So you just add the number in front of the root.
Since they both had the same roots, we could add the number in front together, just like we did on our previous
But you
examples.
don't have to add the I in the front. Or just like cancel out.
No, so we could only add them if they're the same root and the same index, right? And so since they were, we just keep that the same and add the numbers in front together. Okay, so let's go ahead and do B. We're going to do a box again. Notice this time we have some negative numbers. So when I write this down, I have 3 and negative 4 root 2, and then I have 5 and negative 6 root 2. So when we multiply here, 5 times 3 is 15. 5 times negative 4 root 2 would be negative 20 root 2. And then on the bottom, negative 6 root 2 times 3 is negative 18 root 2. Okay, and so now we do outsides with outsides and insides with insides, meaning like the roots and roots, right? So negative 6 times negative 4, and if you want to, you could even write this to the side. So negative 6 times negative 4 is what? 24. And then I'm at root, and it's 2 times 2, which ends up making a pair of 2's. And so 24 times 2 is 48. Okay? And so we have our whole numbers here, 14 and 48, which adds to be 63 is correct. And then we have our negative 18 root 2 and our negative 20 root 2, which will make negative 38 root 2. And that's my answer. Okay, any confusion there? Okay, I'll wait. And I can go back if there's questions. So any questions on this one? So, are we ready for C? Okay, what will I do for C? What does it mean when that is squared?
That means that it's like twice.
It's twice. You cannot distribute the 2 through there, okay? This is root 7 plus 5 times root 7 plus root 5. Sorry, this was a root. So we're going to make a box 2 by 2 again. So far, so good? Okay. Okay. Root 7, root 5. Root 7, root 5. Okay, what will be root 7 times root 7? Yes, because you'd have root 7 times 7, so you'd have a pair of 7s, right? So that's just going to be a 7. Now, when I do root 7 times root 5, would anything be able to come out? No, so that's going to be root 35. Then we go down here, root 7 times root 5 is going to be root 35. And then when I do root 5 and root 5, that will make a 5. So then our part without the roots, we put that in front. 7 plus 5 is 12. And then what is root 35 plus root 35? What number's in front of those? 1. So it's going to make 2 root 35. And if I could break down root 35 and pull something out, I would, but I can't, right? 7 and 5, that's it. Okay, questions? Okay, so previously, when we were rationalizing the denominator, if you look down here, if you look at previous examples when we rationalized the denominator, there wasn't like adding or subtracting anything on the bottom, but now there is. Okay, and whenever you have adding or subtracting in the denominator with roots, you have to rationalize the denominator by multiplying by the conjugate. Okay, so the conjugate, if we come up here, are expressions like root A plus root B and root A minus B. Basically, these are differences of squares. See how they're the same thing, but one has a plus and one has a minus? If you were to factor them, they're similar to differences of square. So the only thing that differs is that in one of the terms has a minus and the other one has a plus. Okay? When you multiply those together, you end up getting a rational number. Okay? Meaning no root. Okay. So if we were to multiply these together, let's go ahead and do our box. Okay? But there is a shortcut that we can kind of talk about. So when I write this down, I have 6 and negative root 12 and 6 and a positive root 12. So again, notice that the only thing that differs between those two numbers is the plus and the minus. Okay? When we multiply 6 times 6, what does that make?
36.
Okay? And then 6 times negative root 12 is negative 6 root 12. And then 6 times positive root 12 is
6 root 12.
good. And then when I do positive root 12 times negative root 12, I'm going to write this to the side. I'm going to have a negative root 12 times 12, which gives me a negative 12. Very good.
Oh, so it's kind of like, you bring it down because you have 12 and it's negative and those two.
Well, we're multiplying, so anytime you're multiplying a positive and a negative, it makes a negative.
Oh, okay.
And then root 12 and root 12 make a pair. Okay, so if you notice here, do you see how 6 root 12 and negative 6 root 12, what happens? They cancel it out because you have a positive and a negative of the exact same thing. So we end up with 36 minus 12. And what is 36 minus 12? 24. Now, shortcut. Since these are differences of squares, this is really 6 squared, your first term squared, minus root 12 squared. And so if you look there, 6 squared is what? 36. Minus root 12 squared is 12, which is exactly what I got when I multiplied this all out. And 36 minus 12 is 24. So using that information, so basically when you're doing the conjugate, you are squaring both the terms with a minus in the middle. You're just basically like unfactoring it. So since this is a difference of squares, I'm just going to put them back as the difference of squares. So if I were to write this one without, you could still do your box if you want to, but the shortcut is that I'm going to end up with root 3 squared minus root 5 squared. So whatever's in the front, I bring that to a square. Whatever's in the back, I bring that as a square. And it only works when you have conjugates. When one is plus and one is minus, that's the only way they differ. What is root 3 squared? 3. Minus, and what's root 5 squared? 5. And 3 minus 5 is negative 2. And if you were to do your box method, you would get the same answer. So the conjugate, this is the way we get rid of roots in the denominator if you're adding or subtracting anything. So notice here at the bottom, the only way to get rid of these roots in the denominator would be to multiply by the conjugate. What would be the conjugate on part A? Exactly. Root 3 plus root 5. And whatever we do to the bottom, we also have to do to the top. So does everybody understand why I'm multiplying by root 3 plus root 5 to the top and the bottom?
To cancel out their denominator, right?
Well, not to cancel it out, to get rid of the roots in the denominator, because you can't have roots in your denominators. Okay, so we can kind of do this as two separate problems. So if you want to do a box, you can, but we know the shortcut way is really root 3 squared minus root 5 squared. And we actually just did that problem on part B above. But root 3 squared is 3 minus root 5 squared is 5. And so my denominator here is what? Negative 2. Now, next thing you would normally do is distribute this through here. But I want you to see something first. So I'm going to write this out. 2 root 7, parentheses, and then root 3 plus root 5. Do you see here how like this has been factored out and how like the 2's could cancel and reduce because they're both on the outside of the multiplication? And so I would reduce these. And this negative could end up going up with the 7. So you have negative root 7 times root 3 plus root 5. And then to simplify this, you would end up distributing. And so when I multiply and I have negative root 7 times root 3, what does that make? Good. And then negative root 7 times root 5 is negative root 35. And neither one of those had anything that I could break into bring pairs and bring things out. Are we good? Any questions? Okay, so B, same thing. We need to get rid of the root in the denominator. And so in order to do that, we have to multiply by the conjugate. And in this case, the conjugate would be what? Good, 3 plus root 6. And whatever I do at the bottom, I also have to do to the top. And so when we multiply the bottom here first, we end up writing that as what?
Root squared minus root 6 squared.
Good. 3 squared minus root 6 squared is correct. And then what is 3 squared? 9. Minus, and what's root 6 squared? 6. And then 9 minus 6 is 3. So that means my denominator is 3, and on top I have 4x, and then parenthesis 3 plus root 6. Is there anything that could be reduced right now before I go any further? No. Because they would both, it would have to be reduced on the outside here, and there isn't anything. So what will I do next? Just distribute through the parentheses. So 4x times 3 is? Good. Plus, and 4x times root 6 is? Good. All over 3. And that's your answer.
You don't.
Can't you use the 12?
Yeah, can't you?
You could. So if you want to write them as two separate fractions, you could do that. So we can go ahead and write that. That could be or. It could be 4x plus 4x root 6 over 3. You would just need to make sure that that 3 is going over both. You could also leave it like this since 3 doesn't go into both of them. You don't have to reduce them, and you can leave them as both of them over 3. But either one of these answers is good. Okay, so C. For time's sake, I normally would have had you guys try these ones on your own, but we are running out of time, so we're going to go through this. So what is my conjugate on C?
1 minus root 3.
Good. 1 minus root 3, and whatever I do to the bottom, I also have to do to the top. When I write this out, I'm going to end up with what?
1 squared minus root 3 squared.
Good. And then 1 squared is 1, minus root 3 squared is 3, and 1 minus 3 is negative 2. So when I write this out, I have a negative 2, and here on top, I have 4 parentheses 1 minus root 3. Can I reduce here at all?
Yes.
Yes. Right? So the 2 cancels, and 2 goes into 4 twice. So this now is negative 2, and then I have 1 minus root 3. Okay, so just don't forget about that negative. And then we distribute it, so negative 2 times 1 is negative 2, and negative 2 times negative root 3 makes, good, positive 2 root 3. So remember that you only multiplied numbers that are not in roots together and numbers that are in roots together. All right. Am I going too fast? You're okay? All right, so what am I going to do on D?
Find the conjugate.
Good, which will be?
2 plus 2 root 8.
Okay. And whatever I do to the bottom, I also have to do to the top. And from there, we're going to write this out. You're fine. You can do it. So we have 2 squared minus, and then 2 root 8 squared. Okay, so when we work this out, 2 squared is 4. Okay, now be careful here because you're squaring the 2 and you're also squaring the root 8. So what is the 2 squared here? 4, and when we square root 8, that becomes 8. And so we end up with 4 times 8, which is,
32.
so we have 4 minus 32. Is everybody okay with that? Okay, and then 4 minus 32 is negative 28. So my denominator is negative 28. And then on the top, I have 3 plus root 8 times 2 plus 2 root 8. Do you notice how this time it's not like a single term that I can distribute? And so I would go ahead, because these aren't the same, they're not conjugates of each other, we should go ahead and use our box to multiply it out. Okay? So I'm going to go ahead and make a box here. And we have 3 and a root 8 on one side, and 2 and 2 root 8 on the other. When we multiply, 2 times 3 is 6. And then I have 2 root 8, and on the bottom I'm going to have 6 root 8. And then I'm going to have what?
3 root 8.
I'm going to have 2 and then root 8 times 8, right? So we have a pair of 8, so that ends up becoming,
8. 2 times 8.
good, 2 times 8, which would be 16. So we can add these together, and 6 plus 16 is 22, plus 8 root 8. Now, can root 8 simplify? Yeah, because 8's really 2, 2, and 2, or 4 and 2, and then you break them down. So a pair of 2's with the 2 left over. And so when I write this fraction right now, I still have my negative 28 on the bottom, and I have 22, and then it's going to end up being what?
16 root 8.
Good, plus 16 root 2. Because there was an 8 on the outside, and we brought out the pair of 2's, and 18 times 2 is 16. Can those reduce at all? Yes, by what? So start by reducing by 2. But all the outside numbers have to reduce in order to do that. So this is 11, this one becomes 8, this one becomes 14. Can I reduce any further? No. So I have 11 plus 8 root 2 over negative 14. And just so you know, this negative can be at the 14, or it could be just out in front of the fraction. Okay, so it just has to be there. And that's your answer.